Okay, this is going to be part 5 of the series on trigonometric substitution. And if you haven't done it yet, I would definitely watch the first 4 videos and it'll kind of give you an idea of how we've gotten up to this point. Now, here's a sample problem we're going to look at. And this will be actually the third of the 3 cases. And we've been going through a set series of steps. Let's take a quick look at those. So again, in the first 4 videos, we looked at this series of 8 steps to solve these problems. Now, the very first thing you have to do is figure out which of the 3 forms you have. So looking at our problem, the problem looks like this. And what you've got, you can rewrite it again. Sometimes it helps to rewrite it, so let's go ahead and do that. So in this case, I'm going to rewrite this as the integral of, and I'll bring it across here. So I've got 1, but rather than 4x squared minus 25, go ahead and rewrite it as something squared minus something squared. So we'll write this as 2x squared minus 5 squared. Because you need to have it in the form of something plus or minus something squared. So something squared plus or minus something squared. So that's what it looks like. So now, which of the 3 cases will it match up with? Well, let's take a look at the cases. Now, in our case, we've got the square root of something squared minus something squared, so it's going to be in this third case. So an x squared minus an a squared. Previously, we looked at a squared minus x squared. So what we've got is a case 3 problem. So the 3 cases, all you have to do is concentrate on these 2 formulas right here, just like you did in the first 4 videos. So with that, let's go ahead and solve this. And again, we'll look the square root will turn into a times the tangent, and u will be a times the secant. So with that in mind, let's go back and look at our problem. Okay, now I think what I'm going to do first of all is go ahead and put these formulas up here where we've got them in front of you. So again, the square root becomes a times the tangent, and u is a times the secant. Now let's look at our steps, and we'll follow the same steps we've done before. So our first step is determine which of the 3 forms you have, and we've done that. Next thing is now go ahead and change the problem from an x problem in terms of a problem in terms of theta, and we'll take care of each part of the square root first, the dx second, and any remaining x's third. So step 2 says change the square root and express it in terms of theta. So in our problem, what that's going to look like, I think we'll do this one in red. This will be step number 2. So what step 2 is go ahead and express the square root, which would be the square root of 4x squared minus 25, and we'll set that equal to some kind of an a times the tangent of theta. Now again, we'll rewrite that as change the 4x squared into a 2x quantity squared minus 5 squared. Now, a reminder, this is what u is equal to, and this is what a is equal to. So in our problem, a is equal to a 5, so this will become 5 times the tangent of theta, and now you've got your square root in terms of theta, so you got part of it done. So now let's take a look at the next step. The next step says now I go ahead and express dx in terms of theta. So let's do that. Now, to express dx in terms of theta, you have to start with this right here. So this will be step number 3. So we'll begin by letting u be equal to a times the secant of theta. So just start with the formula. Now plug in the things you know. You know that u is equal to 2x, so you've got 2x is equal to a is equal to 5 times the secant of theta. Now solve this for x, so that means x then would be equal to 5/2 times the secant of theta. But you need dx, so go ahead and take the derivative. So the derivative of x with respect to theta would be 5/2, and then the derivative of the secant is the secant tangent. So the secant tangent. And then finally, you can write this as dx is equal to 5/2 secant theta, tangent theta, d theta. So now you've got dx in terms of theta. So you've got the second thing. And let's take a look at step number 4. So what step number 4 says is express any remaining x's in terms of theta. Well, in this problem, there are no remaining x's. Again, sometimes you might have an x in the top or another x down here in the bottom, but there are no more remaining x's, so step number 4 is done. You don't have to worry about it. So we go on to step number 5. And step number 5 says, okay, now that you've got all the x's in terms of theta, go ahead and rewrite the integral in terms of theta. So let's do that. So what we'll have, this will be step number 5 down here. And step number 5 says just take each one of these parts and change it into its theta equivalent. So this will become the integral. And then here's the bar going across. And you've got a 1 in the top. Now again, the whole square root turns into 5 times the tangent of theta. So this is going to become 5 times the tangent of theta. Then you've got times, the only thing left is dx, and dx turns into 5/2 the secant of theta, tangent of theta, d theta. So again, just replace each x with what it's equal to. Now, simplify this if you can. So in this case, we can actually simplify it a little bit. So we'll go ahead and do that. You've got a 5 in the top and a 5 in the bottom. So the 2 5s will cancel out. You've got a tangent in the top and a tangent in the bottom. So the tangents will cancel out. And the only thing that you've got left is this 2 in the bottom. So 1/2, you can bring the 1/2 out in front. So that'll be 1/2 the integral of, and the only thing that's left in there is a secant. So that's going to become the secant of theta, d theta. Okay, so again, let's go back and take a look at our steps. So step number 6 says, now go ahead and evaluate this new trig integral. So we'll find this solution in terms of theta. Okay, so you want to find the antiderivative of the secant of theta, and we'll move it down just a little bit here. And this will be step number 6. Now that you've got the constant 1/2. Now just a reminder, the integral of the secant of theta, you may have to look back in your rules to remember this one, but the integral of the secant is equal to the natural log of the secant plus the tangent. Secant theta plus the tangent theta. And then you'll tack on a plus c. Now again, just like in those previous examples, actually this is an answer, but it's in terms of theta. So you've got to change it from a theta problem back into an x problem again, and we'll do it exactly the way that we've done before. We'll just take a quick look at our steps. So the last 2 steps. Draw the triangle and label the sides, and then rewrite the final answer in terms of x. Again, you need the triangle to be able to change the thetas back into x's again. So we'll draw a quick triangle, and again, just draw a right triangle that looks like this. So here's a right triangle. Now I would suggest you go ahead and label the sides. It'll kind of help you figure out what's what. So again, this will be the opposite side. This will be the adjacent side. And this will be the hypotenuse. And I put those on there just to remind you of what each of your trig relationships are. Now, 2 of the sides you're going to have to get from the problem. So let's look back up the problem and see what we've got in this case. So what you've got to work with will be this. You've got 2x is equal to 5 times the secant of theta. So using that relationship, let's go ahead and bring it down here. And you know that 2x is equal to 5 times the secant of theta. And therefore, you'll have 2x divided by 5 is equal to the secant of theta. Now, just a reminder, what that is, the secant is defined to be the hypotenuse over the adjacent. So use this to label your sides. So what you know is that the hypotenuse, and we'll go ahead and put them here, you know that the hypotenuse is 2x. So go ahead and put a 2x on this side. And you know that the adjacent is 5, so go ahead and put a 5 down here. And just like in those previous problems, the remaining side is whatever that original square root was. So the original square root was the square root of 4x squared minus 25. So this remaining side will be the square root of 4x squared minus 25. So now you've got all three sides of your triangle. And now that you've got all three sides of the triangle, you're ready to turn this thing back into an x problem again. So we'll go to step 7. And what you need 1/2 of the natural log of, now again, you need the secant of theta. Well, in this case, you actually had this one earlier. The secant of theta was equal to 2x divided by 5. So this would be 2x divided by 5. And you've got a plus. Now you also need the tangent of theta. So just a reminder, the tangent of theta is equal to the opposite over the adjacent. And now just look at your triangle to get this right. So the opposite side is the square root of 4x minus 25. So this would be the square root of 4x squared minus 25 divided by the adjacent side, and the adjacent side is 5. So this is what the tangent of theta is equal to. So go ahead and put that in right here. So this can be replaced with the square root of 4x squared minus 25 divided by 5. Attach the plus c, and you are done. So again, just kind of go back through the steps again. First of all, take each part of it, and you need to change it from a problem in terms of x into a problem in terms of theta. So go ahead and use this relationship right here, and those two equations will allow you to change those over. And then again, once you've got it in terms of theta, simplify it, find the antiderivative, and now you've got an answer in terms of theta, but you've got to turn it back in terms of x again, and that's the whole purpose of this little triangle. So label the sides of the triangle, and then take each of the trig parts of the solution, and looking at this triangle, turn them back into x again by just picking the correct sides, and you've got the final answer. So there's another sample of trigonometric substitution.